In this video, we will be demonstrating the Hydrology and Rainfall Apparatus, the H313V from TecQuipment. This is a very popular apparatus used in universities and colleges around the world for teaching engineering students hydrology principles, including rainfall, through flow, and the movement of water over land and rivers. In a controlled, contained space, you can simulate multiple and moving storms over different landscapes with varying natural and man-made features such as wells, rivers, and bridge piers. The latest version of the Hydrology and Rainfall Apparatus has versatile data acquisition hardware integrated into the apparatus, which means that when used with a computer running the free software, students can collect, record, and analyze experiment data, including plotting of hydrographs. Further improvements have been made to include more switchable rain banks and even better flow measurement. Let's talk about the context of this in the real world some more. For the design of flood protection and for assessing water capacity for irrigation purposes, it's very important to understand in detail the section in the hydrology cycle where rainfall occurs, creates runoff, and then travels into a stream flow, such as a stream or river. In particular, it is the quality of the runoff and the various factors that affect this that the students can study with this piece of equipment. The rainfall runoff process is fairly complex and is affected by a range of factors. The initial wetness and permeability of the catchment area, i.e. the area where the rain falls, plays a major role. Rain falling on a very dry, permeable catchment will tend to infiltrate the soil rather than move across the surface to the river. On the other hand, striking a wet, impermeable surface, such as rocky ground, will result in a high proportion of runoff. The intensity of the rainfall, i.e. slow drizzle or a mass downpour, plus the slope of the catchment will also affect the quantity of runoff. This equipment allows you to investigate rainfall-runoff relationships for dry, saturated, and impermeable catchments of various slopes. Let's take a look around the apparatus. In total, it is approximately 2.4 meters long, 1 meter wide, and 2.2 meters high. It is self-contained and only requires mains electrical supply. This large, sturdy metal frame holds a large rectangular stainless steel tank, which acts as the catchment area, which can be filled with granular medium, such as sand we have here, to form a permeable catchment area. Below this is the plastic reservoir tank. A jacking mechanism allows you to adjust the angle of the catchment area, and up here there are a series of spray nozzles that constitute 4 sets of rain banks. These simulate the rainfall and can individually be adjusted to simulate a moving storm. At each end of the catchment area are compartments that are separated by weir plates with porous potholes. These can be opened to drain water or supply water to the catchment from the end compartments. In the middle are 2 wells and a row of 20 tappings along the centre line of the catchment area to allow you to measure the water table profile. These are connected to a bank of piezometer tubes at the front of the catchment area. Looking closely at the tappings, you can see each has special slotted ends to stop the permeable media entering its pipe. The wells can be used to understand the drawdown of single or both wells and separately to feed water to the aquifer rather than by using the overhead sprinklers. Experiments include demonstrating dewatering of excavation sites using wells or the flow from a well in a confined aquifer. It also allows you to examine watersheds for a simulated island with a rainfall and well flows, plus measure the cone of depression for a single well compared to that of adjacent wells. Further investigations include the ability to examine loose boundary hydraulics, the tendency of rivers to meander, the transport and deposition of sediment, studies of scour around simulated bridge piers, and demonstration of erosions caused by water through flow. This pump takes water from the reservoir and feeds it to the overhead nozzles and to the ends of the catchment area. To measure flow from the wells and tank, there are magnetic flow sensors that send data to the display on the control panel at the front. The Hydrology and Rainfall Apparatus is part of a range of hydrology engineering teaching equipment available from TecQuipment. For more information, click on the link in the description box below. Thank you for watching.